Hello everyone, this is Arvind Verma and I am math tutor from India, and today we will discuss about exponent and power. So let me allow to share the screen. Okay, the topic is exponent and power. The very first thing is what is exponent and what is power. Can you tell me, have you heard anything about power or exponent? And before going too deep into the exponent, let me clear you that why we should study about exponent and power. What is the logic behind learning this concept? What is the application of the exponent and power in real life? If I ask you the mass of Earth, mass of Earth that is 590, 970, 000, 000, and this much kg. Can you read it? It is difficult to read also. It is difficult to compare with the mass of another thing, like mass of Earth and mass of Sun. If we want to compare these two things, how you will uh, cater these numbers? It's so difficult because it's a very large number. And if I write it like 5.97 into 10 raised to the power 24. It is short and simple. It is short and simple. We can write. I will tell you how I write. I have written this to this form. This is known as standard form. Standard form of exponents. So this is the reason why we have to study exponents so that we can express the large, very large numbers in the standard form so that we can compare it, we can read it. How we will read it? It is 5.97 into 10 raised to the power 24. 10 raised to the power 24. This is our standard form and this is called as power. 24 is called as exponent and 10 is called as base. So 10 raised to the power 24, we read it 5.97 into 10 raised to the power 24. Now in 10 raised to the power 24, in this expression, 24 is exponent, 10 is base, and 10 raised to the power 24 whole expression is known as power. So I think it is clear that why we are studying exponents, large numbers. The same thing apply with the smaller numbers also. Like if I write 0.0000000000 and some random number 789, it is difficult to read like this. But if I write this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 7.89 into 10 raised to the power minus 11, then it is easy to read and short and simple. This is this is your standard form. 7.89. We will discuss in detail, but now it is clear that why we should study exponents and power. Just to read, understand, and compare the very large numbers and very small numbers. Just convert it into the standard form and you are good to go. Like, so in this chapter, we have some laws of exponent. And these laws are very important. So the very first law is if we have some base like a upon b and its power is m into a upon b to the power n, that is equal to a upon b raised to the power m plus n. What is this? What I have written? I have written that a base is a upon b. Why in a upon b form? A upon b is just like p upon q, because a upon b it is a rational number, and we represent rational number in the p upon q form where p and q are integers and q is not equal to 0. That's why we have written a upon b raised to the power m into a upon b raised to the power n. These two are rational numbers, base, and this is rational number. And base are same, a upon b here is and a upon b here is also. So a upon b base is same and multiply is operation is there. So we will add the exponent. The exponent m and n will be added, m plus n. The condition is there is a multiplication sign and base are same, a upon b, a upon b. Now if I have a upon b raised to the power m divided by a upon b raised to the power n, what will be the scenario? What will be the answer? So a upon b raised to the power m minus n. The only difference between this and this is here it is multiplication, here it is division. Base is same and division is there. So we will subtract the exponent. Let's have some example. Let's take 1 upon 2 raised to the power 2 into 1 upon 2 raised to the power 3. So base is here 1 upon 2, base is here 1 upon 2, 1 upon 2, 1 upon 2, and multiplication sign is there. So exponent will be added and base will be same. So base is 1 upon 2 and exponent will be added 2 plus 3, that is 1 upon 2 raised to the power 5. Now take the example of 1 upon 2 raised to the power 2 division. Divide 1 upon 2 raised to the power 3, that is 1 upon 2. Now in case of division, it will become the exponent will be subtracted. So 2 minus 3. So 1 upon 2 raised to the power 2 minus 3 is minus 1. And later on we will discuss. I am writing here it is equal to 2. How it come to 2, I will discuss separately. But for this time, 1 upon 2 raised to power minus 1 is 2. I hope this is clear. If am repeating once, if the base is same and multiplication is there, then base will be there and same base will be there and exponent will be added. And in place of multiplication there is division, then exponent will be subtracted. I hope this makes sense. Let's continue. Let's take one more example. Law of exponent a upon b raised power m and whole to the power n. So if there is a base to the power m and to the power n, two exponents are there. So in such cases, exponents will be multiplied. A upon b raised to the power m into n means mn. Let's take example 1 upon 2 raised to the power 3 and whole raised to the power 5. So 1 upon 2 raised to the power 3 into 5. 3 into 5 is 15. Let's take another a upon b into c upon d raised to the power n. So we will write it a upon b raised to the power n into c upon d raised to the power n. Let's take an example. 1 upon 2 into 1 upon 3 raised to the power, let's say 4. Then it will be 1 upon 2 raised to the power 4 into 1 upon 3 raised to the power 4. Now, very important concept is coming. One second. A upon B raised to the power minus n is equal to B upon A raised to the power n. And one more thing, A upon B raised to the power 0 is equal to 1. Now, let's see how these two laws can be understood by patterns. So, 2 raised to the power A, 4. 1 second. Yes, 2 raised to the power 4 is equal to 2 into 2 into 2 into 2. That is 16. Now 2 is to 3 is 2 into 2 into 2, that is 8. 2 into 2 raised power 2 is 4. 2 raised to power 1 is 2. So what is the pattern? pattern is 4. I am giving some time to you so that you can identify the pattern by yourself. This x, just look at the exponents. Exponents is 4, 3, 2, 1, decreasing by 1 unit. And the result is becoming 16 to 8, 8 to 4, 4 to 2. So what is the pattern? Pattern is 8, 16 to 8 is half, means divide by 2 to the 16. 8 becoming 4 means again half. 4 becomes 2 means again half. So 2 raised to the power 0 will be divided by 2. So 2 divided by 2 will be 1. So this is what a upon b raised power 0 is 1. That is 2 raised power 0 is 1. Now if we step further down, 2 raised to the power minus 1 is again dividing this by 2. So 1 upon 2. So if you compare this law and this law, you will come to know that yes, it is happening. Just look at for a moment. 2 raised power 0 is 1. A upon b is what? Rational number. Rational number to the power 0 is 1. And 2 raised to the power minus 1, that is a upon b raised to power minus n, is b upon a raised to power n, that is 1 upon 2. Let's move further. Do you have any question you can ask? We will repeat whenever you have some doubt. I will try to solve each and every question in much easier way. Let's have some questions. 7 raised to the power minus 3. 7 raised to the power minus 3. What is what we can write? 7 raised to the power minus 3 means exponent is negative. So we have to reciprocate the base 1 upon 7 raised to the power positive 3. That's we just discussed the exponent law of exponent. 3 upon 4 raised to the power minus 3. 3 upon 4 raised to the power minus 3. So you have a negative exponent. Base is 3 upon 4. So reciprocal of 3 upon 4 is 4 upon 3. And minus 3 power will become, the exponent will become positive 3. Now let's discuss 2 upon 5 raised to the power 3 into 2 upon 5. Hello, Arvind speaking, sir. Yes, yes. Actually, sir, right now I'm in an online class. Uh, can I call you on this number after 40 minutes? Yeah, yeah. Thank you, sir. Thank you. Yes. So We have 2 upon 5 raised to the power 3 into 2 upon 5 raised to the power, let's say 2. So what will be the result? Now we have 2 upon 5. This is our base. 2 upon 5. This is our base. And these are exponent 3 and 2. And here is multiplication sign. Whenever there is same base and they are being multiplied, the exponent part will be added. So 2 upon 5 raised to the power 3 plus 2, that is 5. Let's take another example. 5 upon 2 raised to the power minus 5, or 5 upon 2 again raised to the power minus 3. Just for practice, can you tell me the answer? Very good. So the base is 5 upon 2, base is 5 upon 2. Same base and multiplication is there. So base will be same, 5 upon 2 raised to the power. We will add the power minus 5 plus minus 3, that is 5 upon 2 raised to the power minus 5 and minus 3, that is minus 8. Minus 8. Now we'll solve some questions on the exponents. 3 upon 5 raised to the power, let's say, minus 3 into 10 upon 3 raised to the power minus 2. So just try to get rid of these negative exponents. So how to get rid of negative exponents? We have to reciprocate the base. So 3 upon 5, reciprocal of 3 upon 5 is 5 upon 3, and raised to the power 3 into 10 upon 3 is base. So 10 upon 3, reciprocal of 10 upon 3 is 3 upon 10 raised to the power 2. So this will be 5 upon 3 raised to the power 3 will be 5 raised to the power 3, and 5 raised to the power 3 is 5 into 5 upon 3 into 3 into 3 into, now 3 upon 10 raised to the power 2. So 3 power 2 is 3 is to 3 upon 10 is to 10. So 5 2 ja 5 2 ja, and these 2 3s are cancelled out. So 5 upon 3 into 2 into 2, that is 12. This is our answer. Good to go. Let me recap this. 3 upon 5 raised to the power minus 3. So we have to get rid of this negative sign in the exponent. So we will reciprocate the base 3 upon 5 to 5 upon 3 and reverse the sign of the exponent 3. So 5 upon 3 raised to power 3. Same with 10 upon 3 raised to power minus 2. Reciprocate the base 3 upon 10 raised to power 2 and then simply solve it. I think everything is going well and there is no doubt so far. Or you have any doubt, you can ask me. Let's solve this. Minus 5 raised to the power 4 into 3 upon 5 raised to the power 4. Look, here is multiplication. Now base are not same. Here base is minus 5, here base is 3 upon 5. Base is not same, but exponents are same. So we can write, let me give you a concept. Any negative number to the power even number is always a positive number. Always. And any negative number to the power odd number is a negative number. Just you will solve some questions like this, you will be comfortable with this, but for the time being, any negative number to the power even. Let's take minus 2. So minus 2 raised to the power 2. Minus 2 raised to the power 2 will be minus 2 into minus 2. So minus minus plus 2 to the 4. So you are end up with a positive number. That's why any negative number to the power even number is always positive. So minus 5 raised to power 4, it is a positive number, 5 raised to the power 4 into 3 upon 5 raised to the power 4. Now, a raised to the power m into b raised to the power m can be written as a into b raised to the power m. A and b are rational numbers, and this is our law of exponent. Okay. So here is a 5 and b is 3 upon 5. So we can directly multiply it 5 into 3 upon 5 and raised to the power 4. 5 5 cancel. 3 raised to the power 4, that is 3 into 3 into 3 into 3, that is 9 into 9, that is 81. Hope you understood the concept with these examples. Let's solve some more questions. 3 raised to the power 3 raised to the power minus 5 divided by 3 raised to the power minus 7 and whole multiplied by 3 raised to the power minus 3. Now, here division is there and base are same 3. Exponents are different, minus 5 and minus 3. So when base are same and division is there, then we use subtraction of exponents. So base will be this, subtraction minus 5 minus 7 into 3 minus 3. Minus 5 is the exponent and minus 7 is here the exponent. Always, always, always. Whenever there is a negative number, use brackets to avoid mistakes. Now, 3 raised to the power minus 5. Now, when I open the bracket, minus minus will plus 7 into 3 raised to the power minus 3. That is 3 raised to the power 7 minus 5, that is 2 into 3 raised to the power minus 3, that is 3 raised to the power minus 1, that is 1 upon 3. Hope that is clear. Now take another example. 7 raised power 0 plus 5 raised power 0 plus 5 raised to the power minus 1 into, let's say, 7 square. Now we know any number except 0. Any number to the power 0 is 1. So we will write is 1. 5 raised power 0, that is 1. Plus 5 raised to the power minus 1 is 1 upon 5 into 7 raised power 2, that is 2 plus 1 upon 5 into 7 square is 49. Now 5 2 is 10, 10 plus 1 11, 11 upon 5 into 49. Now the task is 11 into 49. So 49 you will write it like this, 4 and 9, and add 4 and 9, 13, 1 carry. So 4 plus 1 5, 5 3 9 upon 5. Let me repeat. Whenever we multiply with 11, there is a shortcut. 49. 49 we will write 4 and 9 separately and add 4 and 9. 9 and 4, 13. It's a two-digit number. So 1 will be carry over to 4. That will become 5. And 3 and 9 will be continued. So 539 upon 5 is your answer. Oh, now let's take another example. 4 raised to the power minus 1 into 5 square upon 2 raised to the power minus 3. So 4 raised to power minus 1 is 1 upon 4. We know 5 square is 25. We know 2 raised to power minus 3. I will reciprocate the base. So it will go to the numerator and it will become 2 raised to the power 3. So 25 into 2 into 2 into 2 upon 4. So this will be cancelled. We will have 50 our answer. I hope it is making sense. Let's take one more example. Minus 3 upon 5. In second. Yes. Minus 3 on 5 raised to the power 3 and whole power minus 2. So there is power to the power. Power to the power, multiply the exponents. So this will be minus 3 by 5 to the power 3 multiply minus 2. So minus 3 upon 5 power minus 6. So this minus 6 means I have to reciprocate the base and remove the negative sign. 6 will be get. So 6 is an even number. So will this negative affected? Yes. Any negative number to the power even number will give positive result. Will give positive result. So it is a 6 is an even number, so it will give me 5 upon 3. Straightforward. 5 upon 3 raised to the power 6. Now, at the beginning, I told you something about standard form. Standard form is like a into 10 raised to the power b, where a and b are any kind of real numbers. But the condition is a will be between 1 to 10, and a can be equal to 1 but cannot be equal to 10 and cannot exceed the 10. And b can be positive, can be negative. If it is a positive number, it is a large, very large number. If b is negative, it is a smaller, smaller number. Let's have some examples. Let's take 3, 4, 5, 6. It is in usual form. This is known as usual form. 3, 4, 5, 6. The way we are seeing the numbers. Now, just ignore 3 and count how many numbers after 3. 1, 2, 3. 3 numbers. So 3 zeros. So 3, 4, 5, 6 into 3 zeros. 1, 2, 3. 1000 divided by 1000. Now I have to solve this. 3, 4, 5, 6 divided by 1000. I will get a decimal number 3.456 into 10 raised to the power. Now 10 into 10 into 10. 10 raised to the power 3. This is our answer in standard form. Let's take another example. Another example. 1 second. Let me make some space. Yes. Let's take any random number. 5, 4, 3, 2, 1, 6, 7, 8. Let's take some numbers. Now I have to write this in the standard form. So ignore 5 and count 1, 2, 3, 4, 5, 6, 7. So multiplied by n 2, 3, 4, 5, 6, 7 and divide 1, 2, 3, 4, 5, 6, 7. So that balance will be there. I have multiplied by same number, divided by same number. Now I have to solve this. I will get 5.4321678 into 10 raised to the power 7. How this 10 raised to the power 7 came? Because of this 7 zeros. Now, if I already have a number in the standard form and I have to convert it into the usual form. So 1.23 into 10 raised to the power 3. This is in our standard form, and we have to convert it. So 1.23 into 10 raised to the power 3 means 1000. So 12330. Let's take another example. 5.5123 into 10 raised to the power 4. So 5.5123 into 1, 2, 3, 4. 10 raised power 4 can be written as 10,000. Now 10,000 will be multiplied by this, so decimal will shift to 4 number. So 5, 5, 1, 2, 3. This makes sense? Now let's take some smaller numbers like 0.000009. So how we can represent this number in the standard form? Simple. We will count the number of zeros till 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And this divide by 1, 2, 3, 4, 5, 6. Now the change is only here that now you have to solve for this number. So here is 6 zeros. So decimal will be shifted right side after 6 numbers. 1, 2, 3, 4, 5, 6. So 9 into 10 raised to the power minus 6. This is 10 raised to the power minus 6. This will numerator will become 9 after multiplication and denominator will be 10 raised power minus 6. Let's take one more example. 0.000000567 like this. So how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this divide by the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will become 5.67. This is result of numerator. Numerator when we multiply these two numbers. And denominator, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 raised to the power minus 9. Let's take one last example. 5 upon 3. Yes. 5 upon 3 raised to the power minus 4. 5 upon 3 raised to the power minus 5. 5 upon 3 raised to the power 3x. So 5 upon 3 into 5 upon 3. Base is same. 5 upon 3, 5 upon 3. Multiplication is there. So exponent we will have to add. Yes, add. So 5 upon 3 raised to the power minus 4 plus minus 5. Always, whenever negative sign is there, use the brackets. 5 upon 3 raised to the power 3x. Now 5 upon 3 raised to the power minus 4 minus 5. That is minus 9. is equal to 5 upon 3 raised to the power 3x. Now base is same in both the side of equality. So exponent has to be same. So 3x is equal to minus 9. So x is equal to minus 9 upon 3, that is minus 3. And that's your final answer. So let's conclude what we did today. We understood the exponents and power, why we are using exponents, what is the application of exponents, what is the reason why we should know the exponents and power chapter, why we should read it. So we looked after that if we have a very large numbers like mass of Earth, mass of Sun, or distance from Sun to Mars, there is a very large numbers that is very difficult to read, comprehend, and compare. So we need exponent form, standard form of exponents so that we can analyze those numbers and compare with each other. Which one is smaller, which one is greater. The same thing apply for the very small numbers. So, and we discussed about the law of exponents, different laws, and with examples we discussed. So try to practice more and more questions on the exponents so that you can have a better practice on your law of exponents. Thank you.